Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about microgrids. So let's dive right into it. Now, first we have to understand what exactly is the problem with our current system. Well, our old method of generating power and distributing in a grid, well, it does work, obviously, that's why we all have electricity, but problem is it's not suited for modern evolving landscape. So that creates a serious issue, meaning our old system was make as big of a reactor as possible, make as big of a power plant possible, and then distribute as far as you can. That's why we went from high voltage to ludicrously high voltage to idiotically high voltage. So that did work, obviously, but it was no longer supporting our current initiative. Our current initiative is green energy. Now you may be like, okay, green energy, it can also work with that. Well, yes and no. While green energy does have multiple mode of energy generation, that's the issue here, because you can have huge solar farms which are producing megawatts of power, as in 200 megawatt, 500 megawatt. India has ludicrously huge one which is around 2000 megawatt, as in 2 gigawatt kind of power scale. And on top of that itself is just one mode of operation. Majority of the solar panels are just used in rooftop solar. So instead of having one giant centralized system, you want a distributed system, and it's far more economical. So you created an issue. Rather, you had old system that was designed for one giant power plant and distributing. Now we have system which have multiple modes of operation, where you have one giant plant and multiple small ones. So what the hell you gonna do? And this also creates an issue with how our peak power plants supposed to be dealt, because we used to build this sort of system, peaker power plants. Now this puppy was sole job was it was always on standby. It's okay, it's not spinning, be mindful, it's not spinning. They are generally jet engine based, because they can spool up very quickly. So they are the moment grid goes to red, basically the demand outstrips the supply, because again, normal power plant cannot just spool up beyond a certain point. If they are built for base load power, their on off is yeah, I'm giving 1500 megawatt, take it or leave it. So in those sort of scenario, they're the moment, let's say, demand goes to 16 100 megawatt of generation capacity would be here just on standby. Okay, turn it on the moment you need to. Now problem, they are ludicrously inefficient. Even as an engine, they are inefficient, because they are designed for instantaneous turn on. If you give it time to spool up, if you give it time extra, design it properly, of course it will work, but again, that will make a base load power supply. These are peaker power plants. Now this is now being replaced with giant battery banks, because while you do have scenario where you have ludicrously high peak demands, you also have time in the grid where you are dude, we are overproducing, and you will be quite surprised how often that happens. So in those sort of scenarios, the battery will charge during the oversupply time and drain during the time of peak demand. So you understand that we are changing the paradigm how we used to work. Before that, we only had the option, make as much as you can. Now we have pumped hydro. People are working with multiple other options, including giant battery banks, which could go up to 100 megawatt hour capacity. So in those sort of scenarios, we have to think differently. Our old architecture was very good us to get till here, but we have to become better at this. Microgrid is a very good solution. How it's solving that? Well, it's simply a grid. It still is the same thing. You have a power plant, maybe solar, maybe wind, maybe biogas, maybe geothermal, whatever have you, but it's isolated. Basically, in last 100 years, we worked our ass off to connect everything to grid. But problem is that created a system. While it is very awesome, it does allow even one energy state to pump power to another one, and it did allows everything to work properly, because again, every generator is synced, frequency is matched, everything is awesome. But it did also create an issue where it's one failure point could literally lead to a whole state, or even district, on extreme worst case scenario, the country going down. India has also had a situation where large chunks of India, almost 1/3 of India, lost power simply because of one fail point. If you have looked into news recently, you would have seen what happened in Texas. That is a very dangerous side effect of having everything connected to one grid, where everything is awesome, but you do have consequence that is 1 point failure. If grid goes down for whatever reason, black starting it is very difficult, and it also creates an issue where it's you are vulnerable to it. And what if your interlink breaks? Not the grid is all intact, but interlink, basically the high voltage lines that you have, if they break. Again, it happens. You live on Earth, or have things like earthquake, flooding, and you have people who can do poor maintenance, or could try to destroy things directly. So in those sort of scenario, microgrid is basically the same thing, only on smaller scale. Basically few megawatts at max, and generally in a smaller district kind of area. District is as big as it can go, and state, again, if you really want to push it, you can push it that far. But the idea is this is completely island capable, meaning if you have followed development of solar energy, you would have noticed people get a lot of subsidy if they have what we call grid tie inverters. What does that do? That simply means it connects, basically does a handshake with grid. Benefit, you don't never have to add battery banks. Side effect, if power goes, meaning your grid goes down, your solar farm is useless. That's the issue that we are talking about here. So islanding is now a feasible thing. Even in your home solar system, you can buy systems that have this islanding ability, where they will be like, okay, we're going to give you a small battery bank. During the daytime, you can use your solar farm as it is, and if you have surplus power, the battery will be charged. If you don't have surplus power and you are running on negative, you have to shut down load, and then you can still have power, like have something rather than nothing. So that's idea scaled up to a larger version. Rather than a single household to a small community, we are talking about microgrids. Islanding under, meaning self-powered, meaning it is capable of black starting. Now, does not, if when I'm talking about islanding, does not mean it can only work in island. Most of the systems are dual mode of operation, meaning it will work as island. In some scenarios, it's actually made in an island, so it has only one mode of operation. But when you are talking about like communities that is being connected, you will have a scenario where it's like it still has a handshake, meaning if they are producing surplus power, they can sell it. If they are in deficit, they can buy it. So it has both abilities. So if the interconnect goes down, link breaks, earthquake happens, things of that nature happens, it's like, I got this. That's the whole point. And it can sync with national grid. Now, generally, scale-wise, this is not a huge project. This is not something that you the world's largest solar farm. It's not something like that. It is very specifically built for small to medium size, meaning basically a small community of rural area to small untouched kind of district where having ludicrously high voltage cable lines that you need to transmit power to that distance would be the way too expensive. It's just not profitable enough. Yeah, in those sort of scenarios, you can use that. Medium scale as in like few megawatts. Now, multiple source input is possible, meaning most of the time generally whenever people are talking about solar systems, it's because, well, solar has become successful. It is at this point in time, the subsidy that are provided with solar is just there just to grease your palm, meaning it's basically helps government rather than building giant power plants. They can just give people subsidy with solar farm and they will reduce their own load. So it is working. It's quite awesome. But you also have other options, meaning if you are in a scenario where solar is not very viable for you, let's say it's a cloudy, but let's say it's a ludicrously windy, you can add wind. If you are in India, you can add biogas. Lot of other things options there. Like if you are in a tidal place, you can have tidal energy. You are in a, let's say, wavy place, you can have wave generators. You get that point. Like you have a lot of options. Add all of them. Then, because we are talking about small scale, right now battery technology is mature enough where you can even have a lead acid battery that can give you 10 kilowatt hour capacity. That is good enough for very small community, to 100 kilowatt hour to megawatt hour lithium ion cells, which are just one container box, which means it can be transported almost around the world. So these sort of things are feasible to do with microgrids, and this will give you community power without having any issue of if outside power is there, awesome. If it's not there, no problem, we still got it. That's the whole idea of microgrid. It will not have the vulnerability of one interconnect fails, this whole section is dark. That will not happen. Basically how it was in the Die Hard movie number 4. Interconnects was destroyed. It's whole state went power loss. That will not happen. Now, what's the logic behind this? Well, you have to understand that many people in India, in Kenya, in basically majority of Africa, majority of Nepal, a lot of places have tried their ass off to make solar a thing, but it had failed most of the time. Solar is becoming very successful in India, where it's people have enough money and middle class people, but not for rural class people. The reason with that is scale, meaning if you give people, hey, this is one solar panel, it does not have too much power. You give them one battery, it does not have too much lifespan, meaning that smaller the cell it is, as in lead acid battery I'm talking, the sooner it's gonna run out of usable lifespan, meaning sometimes as early as 2 years. Again, bigger the battery, then you have some chance, okay, even at the end of, let's say, 5 years, still have some capacity left. So when people try to do that, give you a solar panel, they will give you a solar panel which is very expensive. They will give you a battery charge controller, battery and all that. You are buying too many things and you have a very small LED light bulb capacity 24/7. That's not that useful. However, if you take the same technology, I'm not talking about magical technology, just same goddamn technology, but you compile that into a small station, you can easily get 1 kilowatt to 5 kilowatt, or sometimes even as high as 10-20 kilowatts. At that point in time, it is feasible to add a giant battery bank, which per kilowatt hour capacity wise much more cheaper than smaller systems, and then you can provide electricity to a remote community. Meaning, think of this way, let's say a rural community which is living middle of nowhere basically, and they have nothing. Now if you can give them, each of them, solar panel, it does not work. We have tried it, it failed. But if you create a microgrid system where you have a battery backup, large battery backup, and large enough solar panel where you have enough energy that battery will be charged most of the time, you are in a position where you can give people power without issue, reliably, as in they will have 24/7 power. Again, they will not be using it the same way other you and I use it. They won't have air conditioner on top of air conditioner, refrigerator on top of it. They will only be happy with light bulbs. Their medical shop will be really happy because they have to run a refrigerator for basically keeping the medicine safe. those sort of things can be done because you have a huge unit. Again, think of it this way, like tell a poor person it's like build enough large enough solar farm that you can have like refrigerator running in your house. Yeah, that's not gonna happen. This is one of the things that you have to think about, is like, can the people afford electricity? Because right now, to me, electricity cost does hurt, but can I afford it? Yes, it is painful, but I can afford it. But you go to Kenya or some places rural India and you're like, yeah, we're gonna charge you like 5,000 rupees for electricity. They're like, yeah, no. So that's the whole thing. You are talking about small, and this is how you get them into economical circle, where there's like, hey, just buy a little bit of energy, like let's say only to run a refrigerator. That will be very cheap nowadays with modern refrigerator. And it's like, let's say your production output, meaning if you're selling cold beverages, your shop is doing better. Now you have a money. Now you have money cycle. That's what they are doing, electrifying small communities, because economically it is well supported. And you can, even in this puppy, you need someone to maintain, but here's the deal, because they are only maintaining one equipment, they're like, that one person can like easily wipe this puppy in every night, easily check the batteries, basically distilled water level. They can do everything they have to do on one spot. It's much easier to do, and this literally allows actual real world economical benefit. Expanding is also possible, meaning if you start with this and you start to see, hey, people are actually liking the idea, people have the money, and like, let's say this is one of those light bulb moments where it's like one person starts to use electricity and starts to amplify their profit, other people will also take risk with that. And once you start that trend, more and more people want more and more energy. That's how we got electrification to work in the first place. So this is like doing similar thing, only with renewable from day one, not relying on coal power from day one. So it's renewable from day one. And then technology to do that. This is another aspect of it. It's done. If we have the technology right now, this sort of lead acid, everybody, oh, lead acid is bad. Well, the reason for that is like, most Indian knows how to deal with lead acid battery, because all of us have that for our home inverters. But our inverters are generally have like, basically batteries which are 12-volt units. Problem with that is like, they have lot of capacity, meaning amp power, meaning I have huge inverter which has two batteries, pardon me. So 24-volt multiplied by 220 amp hour, that's the capacity of it. Like, that's huge, like I think around 5 kilowatt hour kind of capacity. But while those are awesome, those are cost effective enough, but they are designed for very short lifespan, meaning I would be really lucky if at the end of like 5 years they will have something left. But this cells, where you are selling each individual cell, they are designed with much thicker plate, meaning they have much longer lifespan. Again, this does not make sense for individual. Generally they are used in railway industry, power plant, basically every substation. You see, substation also has a like a very high voltage DC bus that is powering all the sub equipments, and those could be as high as like 120 volt. Those utilize this. Why? Because they have lifespan of as high as 10 to 25 years. Let that sink. 10 to 25 years on lead acid battery. We hate lead acid right now because we generally use the small ones, which inherently have very crappy life expectancy. So we have the technology, like these are used right now in substations, in power plants, and many places we are utilized that. Now imagine that placed here at that point in time. Again, this whole unit cost, if you asked any home individual to do that, they could not do that. But if a small community pulls enough money or government gives enough subsidy, they're like, it is doable. People are doing this. That's the whole idea. And again, this can be scaled up to very large scale also, meaning 1 megawatt is doable nowadays. And again, I'm talking for rural communities which do not have big bank balance. If you're talking about a corporation that wants to electrify an island, you're talking about around like 600 kilowatt units. People have done that. And when it comes to battery, this is not the only option. This is one of the most mature, stable option that I can pick up a phone, 24-hour Amazon delivery done, go home sweet dreams. You can do lithium ion also if you want to, if you can afford to, you can do that. And many times people do want to do that. So that's the logic behind it. We have tried small unit, it has failed. Compiling them, making them into one large unit is far more financially viable. And when you're talking about large clients, I'm talking this is poor people perspective, but from a large people's perspective, there is another benefit to it also, which we'll discuss. Now in India, this is also becoming a very useful tool for us, because while Indian government did amazing job to trying to electrify every part of India, and we have succeeded to very large extent, given the fact that we have more than 1.5 billion people, you get that point. It is tangibly good achievement to achieve even 60% electrification. That already exceeds the whole population of Europe. So we do have good success, but again, right now still there are more than enough villages that do not have power. The only power they have is solar panels. Now, in those sort of scenario, rather than having very high expensive per kilometer, the cost of high voltage lines are very expensive per kilometer. Rather than that, just having basically independent microgrid there, could literally provide a good stable system, because solar at this point in time is cheap, stable, known technology. We know how this works, because you have to understand solar panel was like, there was one geometric side effect also, because the panels are very small. Side effect of smaller the panel, the more panels you have to add in order to get kilowatt hour capacity, but that was not really good. So now we have panels that are like 300 watts, 400 watts, even some people are claiming as high as like 500 watt panel sizes, which are huge. The bigger the panel, the better it is actually, to just, you reduce the number of screws you have to use, you reduce the number of mounting places, reduce the number of cable connectors, all of those prices goes down, which does become an issue, especially when you are talking about like 10 kilowatt, 20 kilowatt. So it's a thing that people are utilizing it. Then we are talking about lead acid battery. Again, it will not make sense if a home owner wants to do this, but it makes sense if you are trying to electrify a whole village where you do want 24 into hour power. However, one thing I have noticed that India kind of missed on, even though we have a lot of livestock, we have not really looked into biogas properly. And it's not a fault of government. It's one of those ironic situations where it's like, it was too early. For example, my age is around 30 years ago, and I'm pretty sure when I was in school, I was like flooded, like whole of the television was flooded with biogas plants. It's like, get biogas, get biogas. That time, India does not have very good LPG infrastructure. However, government worked their ass off to get good LPG infrastructure. Consequences like we got LPG everywhere. So people are not utilizing this. Now, it does not make sense to have like every milkman trying to have their own system, because again, they will only have like 5 to 6 cows. Only some milk farms have like huge ones, like 500, 600 cows. In those sort of scenarios, it does make sense to have their own plant, because be mindful, you can achieve around 1 megawatt continuous generation 24 into 7 if you just have 100 cows. Like, that's how much energy you can get out of this. Every Indian village, everywhere, even the smallest one, can easily have 200 to 300 cows. So if we add this puppy up, now people did try to do that, but that time it was like using biogas directly as a cooking fuel. That's good use, but not really desirable. People really don't want to pay for that. However, if you combine all of this from a village point of view and use that gas to run engine that gives you electrical energy, now we are talking. Now you have solar as your backbone and this biogas as a secondary system, because it does have the ability for gas storage, meaning you can store gas for like let's say 1 day gas capacity you can easily store. So in case you have to shut down your inverter for maintenance and all that, you can shut it down, run the generator. And you were like, okay, those generators are expensive. Well, no, they are just modified systems. For example, whenever you're talking about vehicles, you can modify the vehicle to run on LNG, which is methane. What is biogas? Mostly methane. So same thing, it can be done. It's like a minor modification, and there are companies that sell you the whole kit if you want. So having two good reliable energy sources can give you really good 24 into 7 power. So this is one of those things that I'm really interesting to see, because solar, every Tom, Dick and Harry is doing that. Awesome. Lead acid batteries, awesome. Biogas, that's the one thing that we are missing. Like, India got it too early, we did not push it through properly. It's like that's our misstep, because we have bored a lot of people. Again, imagine even human feces is added to this, we were talking about gigawatt hour capacity. So boatload of energy is there in the biogas sector, which we have to utilize. Again, biogas, in the old days, people directly wanted to use it as a cooking fuel. That did not work out. LPG replaced it. But as a energy source, awesome. And you may be like, okay, isn't it polluting because it's giving carbon dioxide? No, biogas is just solar energy with extra steps. So what we can expect in the future? Well, this is one of the amazing things, because I have seen many people who do not think things through. And again, they may not have the knowledge. They may not be bad people. They just not have the knowledge about it. Many times people are like, oh, we can't really do anything about climate change, because if you want to pull off people from poverty, you will produce so much CO2 that it will be pointless. Well, no. Simply because this is very good demonstration. Like demonstration in Kenya. Like, I used to think India is poor. While we are not the richest, we're definitely not poor. Like, definitely not poor. And this location, what they did is amazing. What they had is like a place which has nothing. And I'm talking as an Indian. They had nothing. And they're like, here this microgrid, which has only few kilowatts. I'm genuinely surprised. Like, dude, I need that much power to run to my house. But like, again, whole village, all they have is a petrol pump which runs on this electrical power. They have basically shops, bars, which has a refrigerator. That's a big deal for them. And again, medical shop, things of that nature. So they have that plant, and what they did, because again, this is not a high voltage system, directly power coming from this basically inverters from there goes to a smart meter, and there is one smart meter for every client, and the smart meter is on the station side itself. So they directly give you 220 volt line from your basically goes to your household. Benefit, they never have to send a person going there and check your bill and all that jazz. They are like, okay, here, and they use SMS as a billing method. So you can directly utilize SMS directly to, it's like, hey, I want to 10 units of electricity, pay for it, get 10 electricity. It will cut only if there is a power failure or if your credit ran out. So it's kind of awesome. They removed that part also, where it's how the heck you enforce a law. Basically people have to pay for it. They're like, yeah, you pay for it, then you get the electricity. So it's kind of awesome, and it has tangibly improved situation where people are like, dude, I used to run this petrol farm, but I had to use petrol directly to run generator, then to pump a petrol pump. We did not have to do that. Now they have electricity. So it's kind of awesome. Like you can see stories. Like again, it did not work for everyone. For example, hairdresser. Like you will watch the video. There is a hairdresser that is using electric hair dryer. Yeah, that did not work out because that again, electric hair dryer consumes kilowatt of energy. So that did not work as expected for her. But again, for other people, it did work. You have to understand. Again, 5-6 kilowatts, and it's not like very cheap electricity. And again, even if the electricity is cheap, it's not very they are not that rich where they can just afford running a hair dryer. So you get that point. Like it has some limitations, but it was a like for 90 people it was amazing. For 10 people it was not that great, but again, even they enjoyed it because like now their streets have street lamps, they have light. So this is one of those things that really benefited a lot of people and surprisingly efficiently. And the idea behind this is like this, if you start a community based on green energy, that's what they will know. That's how they will understand it. For them point of view, it's like, yeah, we have solar panel. You want more, you put more solar farm. They will never have to worry about coal addiction. They will never have to worry about oil addiction, because that's from day one they are learning how to do green, reliable systems. So from that's like building a better future without having the consequence, oh, they still have to go through coal phase. No, they don't, directly. And this also, if you start to implement this sort of thing on a small district area kind of scenario, it boosts regional stability, which was like a very critical thing during India's coal shortages, which happened like due to poor management. And again, there were other things also, because sometimes nature has its own plans. So bad things happen. Consequence, surprisingly large area of India went to dark. Same happened in basically Texas in USA. Same happens once in a while in Europe also. So this is one of those things, because our grids are so interconnected. It's like one point failure, everything goes poof. Again, microgrid gives stability to that. And it reduces power bill for corporations. Corporations are pouring their money into it to make themselves into an energy island. Why? To give you a context, my brother used to work in a cement factory, where it's like he was the industrial health expert, basically the doctor of that plant. And that plant had a lot of workers. That lot of basically senior staff had their families tended to basically colony. That small colony had half megawatt energy consumption. They literally built half megawatt solar farm just to feed that basically colony, not the main cement manufacturing system, just the main colony building. But you get that point. Doing that, again, it would have costed them a boatload of money, but benefit, you run that like 5-6 years, their return on investment was practically done. From day one, the return on investment was done, and the plant's supposed to work for at least 25 years with major renovations at 10 years point. So they had to do that. And think of this way, let's say you are in a position where you are dealing with a dairy product. You have boatload of biomass. Add biogas also, add solar also, add, if you are lucky, if you are in a location where you have wind, add that also. In that sort of scenario, you have a lot of control, and then you have reliable energy at a fixed rate. Every corporation wants fixed rate electricity, which grid is not providing. Grid is like, how about we make it up? How about we have a peak power demand? How about right now we just YOLO it? So this sort of thing is a very big issue for companies that are trying to produce products. So in those sort of scenarios, they really want control over that. And if control is done by reducing carbon footprint, GG. They don't care about carbon footprint. They're like, hey, do this, and it saves them carbon footprint. They're like, why should I care? It's like, oh, do this, it saves you money. Shut up and take my money. So that's one thing you have to understand. You do not want to sell product because like it's better for environment. You want to sell it, it's better for you. So that's the whole thing. And if people did that, which they are already starting to do, it's also already reducing CO2 emission. It's already adding people to the electrical grid without creating like, the same side effect of like, oh, we have billion people adding to carbon production. No, they don't. And again, if they directly start from this, they know for a fact that energy is something that they have to think before spending it. Imagine they directly start to add biogas to their system, other systems, biomass systems. If from day one they are starting to do it, they will do much better job than any other country can do, simply because again, they had a better, cleaner start. And this has use from everybody, from rich people to poor people. And this is one of those things that is like, it's not new, it's not whoa, it's like, it's like, what if I add this to this? Amazing things. So I'm really happy with this development, because that Kenya story was really eye-opening, where it's like, that's smart. And again, I know places in India, I have been to those places in India where a lot of solar lamps was created, all of them failed. Simply because, again, if you have 2 panels, they're not that efficient. Add 20 panels, now we are talking. Add, like, if you have multiple small cells, rather than having multiple cells, have huge cells which have long lifespan. Now we are talking. You get that point. Like, there are many times where scale does translate you to success or failure. And I've seen more than enough failed projects where I'm like, yeah, I get it now. And seeing the financial benefit of something like this, it's like, yeah, it does work. And again, we can do better, we can improve it, and we are working on it. People are working on making hydrogen energy cell storage system where they're smart, where they're like, yeah, hydrogen is really not good for energy carrier. However, for vehicles, it's priceless. So if you have hydrogen truck industry, it's like you do store, basically create hydrogen when you have surplus, sell that hydrogen to the vehicle industry. And I like that idea. That's far more efficient use of it. So you get that point. There's a lot of option you can do and make that whole area robust. Imagine thousands of areas that are far more robust than, like, one interconnect fail, okay, this whole state or country goes down. So this is amazing development. I really like this. So this was my presentation on microgrids. Hopefully you have liked it, learned from it. In that case, please click like, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice if it makes you feel better. Leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.